Hey everyone, it's Miss Joyce. Today we'll be adding and subtracting fractions with unlike denominators using visual models. First, let's add 2/3 plus 1/2. We'll first represent each of these fractions using visual models. Let's represent 2/3 by shading in 2 out of the 3 parts. We're adding this to 1/2, which means that we'll shade in 1 out of the 2 parts. If we look at both these fractions, we can see that the sizes of each of these parts is not the same. When we're adding and subtracting fractions, we need to make sure that the size of each part is the same. So what we can do is create equivalent fractions to make it so that the sizes of each part is the same so we can add them together. To do that, we can list out the multiples of the denominators, which is the number that's on the bottom. So let's start by listing out the multiples of 3, since that's the denominator of our first fraction. We'll list out the first 5 multiples of 3. So we have 3, 6, 9, 12, and 15. Now we're going to list out the first 5 multiples of 2, since 2 is the denominator of the second fraction that we're adding. Here we have 2, 4, 6, 8, and 10. Now what we can do is look at both of these lists to find the first number that is in both of the multiples lists. If we look carefully, we can see 6 is the first number that's listed in both of these lists. That means that 6 is going to be our common denominator. So when we're creating equivalent fractions, we're going to rewrite each fraction so that the denominator is 6. So let's start by rewriting 2/3 as 6. What we can do is break up each of these 3 parts into 2 pieces. Now we have a total of 6 parts. Out of those 6 parts, we can see that 4 of them are shaded. So that means that an equivalent fraction to 2/3 is 4/6. Another way we can get this is by multiplying. So if we know 6 is going to be our common denominator, what we can do is ask ourselves, what do we multiply by 3 to get to 6? Well, 3 times 2 equals 6. Remember, when we're creating equivalent fractions, whatever we do to the bottom, we must do to the top. So since we multiplied by 2 on the bottom, we need to multiply by 2 on the top. 2 times 2 is 4. So this is another way to get the equivalent fraction 4/6. Now let's find the equivalent fraction to 1/2 when we rewrite it as 6. Here we have 2 parts. We're going to break each of these 2 parts into 3 pieces so that we have a total of 6 pieces in the entire whole. We can see out of those 6 pieces, 3 of them are shaded. So that means an equivalent fraction to 1/2 is 3/6. Another way we can get this is by asking ourselves, what can we multiply by 2 to get to 6? Well, 2 times 3 equals 6. So since we multiply by 3 on the bottom, we're going to multiply by 3 on the top. 1 times 3 equals 3. So this is another way that we can get 3/6 as our equivalent fraction. If we look at the equivalent fractions, we can see that they are both represented with 6 parts. And if we look at our visual models, we can see that all the parts are the same sizes. So now we can add them. So we're going to add 4/6, since that's the first equivalent fraction, plus 3/6, since that's the second equivalent fraction, to get 7/6. And that means that there are 7 parts shaded, 1, 2, 3, 4, 5, 6, 7, out of 6 parts in each whole. So if we look at just one whole, we can see that there are 6 parts. So 2/3 plus 1/2 equals 7/6. Let's try another problem. Here we have 1/3 plus 3/4. First, we're going to create visual models to represent each fraction. For 1/3, we're going to have 3 parts with 1 of them shaded. For 3/4, we're going to have 4 parts with 3 of them shaded. If we look, we can see that the sizes of each part are not the same. In order to add and subtract fractions, we need to make sure that the parts are the same sizes. So we're going to create equivalent fractions. To do this, we can list out our multiples of our denominators to find a common multiple or a common denominator. Since 3 is the denominator of our first fraction, we're going to list out the first 5 multiples of 3. So we have 3, 6, 9, 12, and 15. Now we're going to list out the multiples of 4, since 4 is the denominator of our second fraction. Here we have 4, 8, 12, 16, and 20. If we look at both of these lists, we're trying to find the first number that we can locate in both lists. We can see that 12 is the first number or the first multiple of both 3 and 4. So that means 12 is going to be our common denominator. So we're going to break up each of these wholes into 12 parts. Well, for our first fraction, we have 3 parts. So we're going to break each part into 4 pieces to create a total of 12 parts. If we can see there's 12 parts, 4 of them are shaded. So that means that an equivalent fraction to 1/3 is 4/12. Another way we can get 4/12 is by asking ourselves, what do we multiply by 3 to get to 12, since 12 was our common multiple? Well, we know that 3 times 4 is equal to 12. So whatever we do on the bottom, we must do on the top. So since we multiplied by 4 on the bottom, we're going to multiply by 4 on the top. 1 times 4 is 4. So this is just another way to get the equivalent fraction 4/12. Now let's find the equivalent fraction to 3/4 when we rewrite it as 12ths. Right now we have 4 parts. We're going to break each of these 4 parts into 3 pieces to get a total of 12 parts. We can see that out of the 12 parts, 9 of the parts are shaded. So that means that an equivalent fraction to 3/4 is 9/12. Another way we can get 9/12 is by multiplying. So what we're going to do is ask ourselves, what do we multiply by 4 to get to 12, since 12 is our common multiple in both of the lists? Well, we know that 4 times 3 equals 12. So since we multiply by 3 on the bottom, we're going to multiply by 3 on the top. 3 times 3 equals 9. So this is another way we can get 9/12 as an equivalent fraction. If we look at our equivalent fractions, we can see that they both have denominators of 12, which means that each whole has 12 parts in it. If we look at both of our visual models, we can see that the sizes of all the parts are the same. So we can now add these fractions together. 4/12 plus 9/12 equals 13/12. That means that out of both of these fractions, 13 parts are shaded, and the 12 shows that there are 12 parts in each whole. So 1/3 plus 3/4 equals 13/12. Now let's try a subtraction problem. Here we have 1/2 minus 2/5. We're going to go ahead and start the same way by rewriting or representing each of these fractions with visual models. Here we have 1/2, so we're going to have 1 part shaded out of 2. We're subtracting 2/5, so that means we're going to shade 2 out of the 5 parts. Well, if we look at both of these visual models, we can see that the sizes of each part are not the same. So we need to create equivalent fractions so that the sizes of the parts are the same. What we can do is list out our multiples of our denominators. Since 2 is the first denominator in our first fraction, we're going to first list out the first 5 multiples of 2. We have 2, 4, 6, 8, and 10. Now we can list out the first 5 multiples of 5, since 5 is the denominator of our second fraction. We have 5, 10, 15, 20, and 25. Now let's look at both of the lists to see which multiple comes up first in both lists. Well, we can see that 10 is the first multiple in both lists, which means that 10 is going to be our common denominator. We are going to rewrite both of these fractions so that they each have 10 parts. So let's first rewrite 1/2 so that there are 10 parts. Well, we have 2 parts right now, so we can break each of these 2 parts into 5 pieces. We now have a total of 10 parts. We can see that 5 of those 10 parts are shaded. So an equivalent fraction to 1/2 is 5/10. Another way we can get 5/10 is by asking ourselves, what do we multiply by 2 to get to 10? Well, 2 times 5 equals 10. And remember, we got this 10 because that was the first common multiple in both of our lists. Since we multiply by 5 in the denominator, we're going to multiply 5 by the numerator. So 1 times 5 equals 5. So this is another way that we can get 5/10 as our equivalent fraction. Now let's create an equivalent fraction for 2/5. Once again, we're going to break this whole into 10 parts. Right now there are 5 parts, so we're going to break each part into 2 pieces. Now we have 10 parts altogether with 4 of them shaded. So an equivalent fraction to 2/5 is 4/10. Another way we can get 4/10 is by asking ourselves, what do we multiply by 5 to get to 10? Well, 5 times 2 equals 10. So since we multiply by 2 on the bottom, we're going to multiply by 2 on the top. 2 times 2 is 4. So that's another way that we can get 4/10 as our equivalent fraction. So now let's look at the equivalent fractions. We have 5/10 and 4/10. We can see that by the common denominator 10, each of the parts are the same sizes since each whole has 10 parts in it. Since the denominators are now the same, we can go ahead and subtract these fractions. 5/10 minus 4/10 equals 1/10. So 1/2 minus 2/5 equals 1/10. Let's try one more problem. Here we have 5/6 minus 2/3. First, we'll represent 5/6 with a visual model where we'll have 6 parts and shade 5 of them. We'll also represent 2/3 with a visual model by having 3 parts and shading 2 of them. The sizes of each part is clearly not the same, so we need to create common denominators to rewrite both of these fractions as equivalent fractions. So what we're going to do is list out the multiples of each denominator, starting with the denominator 6, since that's the denominator of our first fraction. Here we have 6, 12, 18, 24, and 30. Now we can list out the multiples of 3, since 3 is the denominator of our second fraction. We have 3, 6, 9, 12, and 15. Let's look at both these lists to find the first multiple, or the first number that we can see in both lists. Well, we can see that 6 is the first multiple in both these lists, which means we can break each whole into 6 parts. Well, if we look at this first fraction, 5/6, we're actually already in 6. There are 6 parts in this one whole. So we don't have to do anything here. We don't need to create an equivalent fraction since there are already 6 parts. So now we just have to create an equivalent fraction to 2/3. We're going to rewrite 2/3 as 6. So since there are 3 parts, we can break each part into two pieces. We now have a total of 6 parts. We can see that 4 of the 6 parts are shaded. So 2/3 is equivalent to 4/6. Another way we can get 4/6 is by asking ourselves, what do we multiply by 3 to get to 6, which would be 2. So since we're multiplying by 2 on the bottom, we're going to multiply by 2 on the top. 2 times 2 equals 4. So that's another way to get 4/6. We can now see that 5/6 and 4/6 have common denominators. So now we can subtract these fractions. 5/6 minus 4/6 equals 1/6. So 5/6 minus 2/3 equals 1/6.